Hello viewers, I Dr. Mala Das Sharma welcome you to my video number 133 of my channel MALACHEMPHILIC. And video number 133 is the episode number 72 of Chemical Thermodynamics, where the topic is multi-component phase equilibrium, and under this vapor pressure lowering and Raoult's law. So let's start. Now, first we should know this vapor pressure concept. See, if you take one liquid, say volatile liquid, and some of the liquid will get vaporized and vapor will be above the surface of this liquid, and this vapor which is present above the surface of this liquid will exert a pressure on the surface of the liquid that is known as the vapor pressure of that liquid. So this vapor exerts a pressure on the surface of the liquid. Okay, that is the vapor pressure. And suppose all these are closed systems. So at a particular temperature, this maximum pressure exerted by the vapor which is present above the surface of the liquid is known as the vapor pressure of that liquid at that temperature. Right? Now, when a non-volatile solute is added to a solvent is volatile, little bit of non-volatile solute is added, then vapor pressure of the pure liquid decreases or lowered down. And this is known as the lowering of vapor pressure due to addition of non-volatile solute. That means the vapor pressure of the solution is less than that of the pure solvent. Now, what is the reason? See, here initially pure solvent is there and solvent is volatile. So from the surface of the solvent, these volatile molecules are vaporized and going to the vapor phase, which is exerting pressure on the surface of the liquid, that is vapor pressure. Now when you are adding little amount of non-volatile solute, because it is dilute solution, then few portion of the surface of the liquid is occupied by the non-volatile solute, and that non-volatile solute cannot be vaporized. So as these few portions of the surface are occupied by the non-volatile solute, the solvent molecules from those portions cannot get evaporated or cannot be vaporized. So less number of solvent molecule can go to the vapor phase or can be converted to vapor. As the amount of this vapor is less due to less vaporization, so this vapor pressure also lowered down or decreases due to addition of non-volatile solute. So the decrease in the vapor pressure of the solvent is caused by the presence of few molecules of non-volatile solute at the surface, with the result a fraction of the surface of the solvent is blocked to evaporation. Just now what I explained. So if P0 is P0 is the vapor pressure of the pure solvent, which is volatile solvent, and P is the vapor pressure of the solution, that is after addition of little bit of non-volatile solute, then lowering of vapor pressure due to addition of non-volatile solute will be P0 minus P, and then relative lowering of vapor pressure will be P0 minus P by P0, that is relative lowering of vapor pressure. Now coming to the relative lowering of vapor pressure and Raoult's law. So what is Raoult's law? Raoult's law states that this relative lowering of vapor pressure due to addition of small amount of non-volatile solute in a volatile solvent is equal to the mole fraction of the solute in the solution. But some conditions are there, provided the solution must be dilute and solute must be non-volatile, and the solute does not undergo any association or dissociation in the solution. So, according to Raoult's law, this relative lowering of vapor pressure will be equal to mole fraction of this non-volatile solute in the solution. So, X2 is the mole fraction of the solute in the solution. Now, we'll derive this Raoult's law. See, we know that according to Raoult's law, according to Raoult's law partial vapor pressure of the volatile component in an ideal solution. What can I write? Already I have derived this equation, that is P is the partial vapor pressure of this component, one component, say it is solvent component, that is equal to P naught, that is vapor pressure of the component in the pure state at the same temperature, into X. X is the mole fraction of that component in the solution. So this X, mole fraction of the component in the solution. Mole fraction of the component in the solution. Okay. Now, since all the dilute solutions are ideal, dilute solutions are ideal. So what can we write? So the vapor pressure of the solvent of the volatile solvent component of a dilute solution of one non-volatile solute, what I can write? Same thing I can write, that is P is equal to P naught. This is the vapor pressure of the solvent. Okay, P naught into X1. X1 is the mole fraction of the solute. So this is mole fraction of the solvent. Okay, so this one I can write it as P is equal to P0 or P naught 1 minus X2. What is X2? X2 is the mole fraction of the, this is mole fraction of the solute in the solution. Okay, so from here I can write P is equal to P0 minus P0 X2. So from here I can write, if I take P0 X2 this side, that means P0 X2 is equal to P0 minus P. So therefore what can I write? I can write X2, that is mole fraction of the solute, is equal to P0 minus P by P0, that is relative lowering of vapor pressure, that is Raoult's law. So this relative lowering of vapor pressure is equal to the mole fraction of the solute, that is non-volatile solute here, in the solution, that is Raoult's law. So this vapor pressure of the pure liquid is lowered down due to addition of non-volatile solute, which is known as the lowering of vapor pressure due to addition of non-volatile solute. And then this relative lowering of vapor pressure due to addition of non-volatile solute is equal to the mole fraction of the solute in the solution. That is as per Raoult's law.